Welcome back, my algebraically minded minions. Well, as we travel on this journey, which is this first unit of algebra, as we look at these relations and functions, before we can get knee deep in this stuff, before we can actually start talking about the different function families, we've got to first deal with some key features of the graphs. We've got to talk about some key components, some important definitions and things that we need to understand, that we need to have a firm grasp over before we can be successful. So let's first start off with looking at this graph, this XY graph. Obviously, this is the x-axis, this is the y-axis. This Cartesian coordinate plane, as you learned from last year. Okay, a couple things we need to understand about it. First of all, in this, when we start looking at numbers on the x-axis, as we travel along this right here, this place right here where the x and y-axis meet, this is called the origin. It is the beginning. Its value, its location is 0, 0 on the coordinate plane. Okay, and as we travel along this x-axis to the right, these numbers are all positive numbers. As we travel to the left from 0, these numbers these are negative x's. So we've got positive x's and negative x's. Okay, and as we travel up along this y-axis, these are positive y's. And as we travel down, these are our negative y's. So there's the first important thing. Secondly, when we look at these, we have 4 sections in here. They're called quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And last, we have quadrant 4. So we need to be able to recognize those. And also, when we deal with ordered pairs, when we deal with these coordinates that tell us a location, for example, we talk about the location. This is 2 to the right and 3 up. This point right here where A is, this would be the location 2, 3. This first number is our x value, where we are on the x-axis. The second one is our y-axis. So we look at those. It's important that we understand those key points about a graph. When we talk about an origin, we talk about positive and negative numbers and all of that. Okay, so next, let's go ahead and let's start describing these things. Let's look at specific ones. So describing the change. Well, there's a couple of changes we can have that go on in a graph. First of all, a graph can be going in an upward direction. This we would say that this is increasing. This graph is increasing, okay? Or that it is positive, that it's a positive. Second, we could have one that's going some downward direction, okay? So it is decreasing. This is decreasing. It's going downward. It is a negative. It is a negative graph. And then the next change that we can be dealing with is what we say is a constant graph. It is constant. The reason it is constant is because it is neither increasing nor decreasing. It's not going up, it's not going down, it's simply constant. Okay, so we have increasing, we have decreasing, and we have constant. Those are the 3 options we have as far as change that's taking place. Now, next let's talk about classifying some data. There's 2 types of data. Now, when I say data, I mean the information that we're putting on the graph. The information, those points that we're plotting. Why is it that we're graphing? What type of data are we dealing with? Well, we can deal with continuous data. Continuous data. This just means that this is when we have some sort of straight line. It doesn't have to be curved. It could be straight. It doesn't have to be going like that right there. That's just it could be this way. It could be going down, anything, but it's continuous. It is a solid line. It involves some type of measurement. Continuous means that we're dealing with every portion of it. The second thing is discrete. Discrete is when our data is made up of unique points. For instance, if we were graphing something, we were talking about how many people can ride in a certain type of vehicle. Well, we can't have 2.3 people riding in there, so we would use discrete data. We would use points on there. So if you look at a graph, if it has solid lines, we say it's a continuous graph. If it has dotted lines, just dotted points, we say it's discrete. So that's the classifying the type of data. So we look at those 2 types, continuous and discrete. Okay, so now we get to some key terminology, some definitions. So you may have to pause as we're going along here so that you've got time to go ahead and write each one of these down as I do and go back and look at them. So first of all, the vertex. The vertex. Well, this is where a graph changes directions. So this is somewhere where we have a direction change. Now, will every graph have a vertex? No. Okay, this is where a graph stops going up and starts going down, or stops going down and starts going up. So that's the vertex. It's where you have a direction change. Now, in behavior, this is what is occurring on the graph as it approaches positive and negative, and you'll see this symbol, positive and negative, as it approaches positive and negative infinity on the x-axis. Okay, so as we look at the x-axis, so as you go to the left, as you go to the right, what's happening to the graph as it approaches infinity? Okay, is it increasing? Is it decreasing? As we get closer and closer to infinity, maybe it's getting closer to zero. What's it doing? At the end of the graph, at the far extremes, off your page, what is it doing there? Okay, so the next one, the domain. The domain, well, this is the inputs. This is the inputs or the x values. So the domain is the inputs of the x values. So this is saying, when we talk about the domain of a graph, it's what x values, what input values are possible, are represented. Not just the ones that you plot, but any of them that are possible for it. Now the range, this is the outputs, okay? This is the outputs or the y values, Now, here again, be careful, because the range, how high it goes and how low it goes, it could go to infinity, okay? To try to quote Buzz Lightyear, it could go to infinity and beyond. But obviously we can't draw a line that goes to infinity. We can't draw a line to go forever. We'd run out of lead. Our hands would fall off. We would have those issues. But we know that lines go on forever. So we would say that it would go to infinity, or wherever it goes to. It may have a stopping point. Your graph may go to a certain point. It may go down the lowest it may go. It may change directions at -5. So the range for it may be from -5, and it may go up to +3 and then change. So you can have all kinds of things right here as we start to talk about. Now, the y-intercept. This is where the graph crosses or intersects the y-axis. It's where it crosses, where it intersects the y-axis. Okay? So it's where it crosses, where it intersects the y-axis. That coordinate, that point is called the y-intercept. Now, the cool thing about every y-intercept when we deal with it, because we're crossing the y-axis there, the x value will always be 0. So this coordinate will always look like 0 and then whatever that y-intercept is. Okay? So there, the x value will always be 0 at the y-intercept. Now, the x-intercept is where it intersects. It's where the graph intersects or touches or crosses. It's where it intersects the x-axis. Okay, so will every graph cross the x-axis have an x-intercept? No, some of them don't. Some of them do not cross the x-axis. But if it does, it's called an x-intercept. And much like when we talked about the y-intercept, the cool thing about it is you can always tell an x-intercept, the coordinate. It's going to be whatever it crosses, but the y value will always be 0 when you look at it. The y value is 0 on an x-intercept. It's because it's right there on the x-axis. Now, maximum or minimum, okay? This is the highest or lowest point. Highest or lowest point on a graph. That's called the maximum or minimum. If it's a highest point, it's called a maximum. How high? Well, it's going to be a y value. It's when the y is at 200, I don't know. Or how low does it go? Okay, what's the lowest value, the lowest point that it goes? Now, the next one, the last one we need to deal with is interval of increase or decrease. Now, interval means a period of time. So that's interval. So it's saying what period of time is it increasing? What period of time, when is it increasing, when is it decreasing? Now, interval of increase, interval of decrease will always be in relation to your x-axis, in relation to your x values. So everything we talk about, if we say that it's increasing from -4 to 1, well, that means when x is -4, when x is -3, when x is -2, when x is -1, when x is 0, when x is 1, okay? So those are all periods where it's increasing or decreasing, whatever. It's all in relation to the x-axis. All right, so this is a key terminology. Now, let's look at a specific graph and let's talk about some of these key features. Okay, so let's examine one of these and talk about this. So if we had some sort of graph that so this one that we looked at, it looks like this right here. So when we talk about this one, we talk about some key features of it. Does this one have a vertex? Vertex, does it have a place where it changes direction? Yes, this is the vertex, okay? This is the vertex. It changes direction. Notice that as we examine this thing, okay? So as we examine it, as we look at this side over here, okay? Over here, it's going, here the graph is going up to the point, okay? This graph over here is going up to this point, and over here it's going down to this point. So the vertex is right here. This is the vertex. Now, this vertex here happens to be the highest point. So it's not only a vertex, but it's a maximum. So this vertex is not only a vertex, but it's a maximum. Okay? Other key things. Right here, this point right here, this is a y-intercept. That's a y-intercept. It's where it crosses the y-axis. Okay, so it's where it crosses the y-axis. So other things, notice that here and here, this one happens to have two x-intercepts. The x-intercepts. This one has two x-intercepts. These are x-intercepts when you look at it there. So that's the x-intercepts. Now, when you talk about things like the domain, what are the x values? Well, if we see this thing, it's going down, it's got the 0. That means it keeps going forever. So how far will it go to the left? It's going to go to infinity. So the domain here, we would say, is from negative infinity, and I'm going to write this in, okay? So it's going to go from negative infinity, we're going to write this, to x, because we're talking about the x values, and how far does it go? Well, it goes, and excuse me, it can't be equal to infinity. Okay, so it goes from negative infinity all the way to positive infinity. That means it's going all the way to the left, all the way to the right. So it's going forever in those. So the domain is negative infinity to positive infinity. So what would the range for this thing be? Well, here again, the range. We go, how low is this thing going to go? Well, it's going to go to negative infinity. So negative infinity less than y, because we're talking about the y value, is equal to, now I'm going to put the equal to, why? Because we know how high does it go. How high does this go? There's 1, there's 2, there's 3, there's 4, there's 5. It's going to go up to 5. So the range goes from negative infinity forever down here at the bottom, all the way up to 5 till we get to 5, and then it stops. So there is our range. Now we look at those things. Interval of increase. Where is this increasing? Well, it's increasing over here. So everything from here, how far is it increasing? Notice this graph. It's going up to the vertex, to the maximum. So the interval it's increasing from negative infinity all the way until it gets to right here. So where would it be increasing from negative infinity to -1? So where is it decreasing? Well, it starts decreasing here at -1, and it decreases on the x-axis forever. Why? Because it's going down. Okay? So that's it. That's examining this one. Hopefully this will give you a little taste of it. We will work more of these in class. We will talk about them, but this should give you some insight. Look over this, study it, write down some questions. You should have lots of them, especially after I put this graph up. And I will see you in class with questions, and we will go from here. Next stop, parent functions.